Okay, good evening. Okay, this is Professor David J. De Los Reyes. The date for tonight will be November 25, 2023, and the time is 8:33 p.m. Okay, my topic for tonight will be a continuation of my long video format topic, trigonometry, and I am now on lesson number 29. So for tonight, we'll be discussing a long video format, trigonometry. Okay, let's proceed. The subject matter for tonight. So for those of you who are following my channel on the topic trigonometry, the lesson for tonight will be trigonometry lesson number 29, and the title of the topic will be example problem on sine of the sum and difference of angles. The last time around, I derived the two formulas on the so-called expansion of the sine of the sum and difference of two angles. That is, sine of the quantity angle A plus angle B is actually sine of angle A, cosine of angle B, plus cosine of angle B, sine of angle B, if the operation is plus. And the sine of the quantity A minus B is actually the sine of angle A, cosine of angle B, minus cosine of angle A, sine of angle B. Okay. I will now try to give you an illustrative example on the application of the so-called sine of sum and difference of two angles. Okay, example number one. Example number one, it's an easy one. It's just an illustrative example applying the sine of a sum of two angles. That is, find the sine value of 75 degrees and what will be equal to. So by using the concept of the derived equation the last time around, we'll try to solve this problem. Okay, let's try to bring out the sine of 75 degrees. If you try to bring out the sine of 75 degrees, okay, and without using table or calculator, there will be a problem. But if you know how to use the sine of the sum of two angles, actually you could derive the value of the sine of 75 degrees without even using calculator or tables. But you must have to know the value of the so-called special angles. Special angles in the study of trigonometry are actually the 30 degrees, 45 degrees, and 60 degrees. For these three angles here, these are special angles. Why they are called special angle? Because for those who have studied trigonometry, or for those who have already become engineer, okay, they know for a fact the values of this one without resorting to calculator or what you call this table, like 30 degrees. The hint for a 30 degrees is that to memorize the value of the sine, cosine, and the different functions under 30 degrees, you must just have to determine that sine of 30 degrees is equal to 1/2. By just knowing the value of sine of 30 degrees to be equal to 1/2, you could derive the other values. Okay? So whether you are sleeping, you are eating, or maybe you are doing something, at least you know that if the angle is 30 degrees, the sine of 30 degrees is 1/2. Okay, this will not change. Because if you know the sine of 30 degrees, you could derive the other values of 30 degrees. You could derive the value of the cosine, the tangent, or of course the reciprocal functions, you could derive it already. So by knowing sine of 30 degrees to be equal to 1/2, there will be no problem. How about 45 degrees? How about the hint for a 45 degrees? The hint for a 45 degrees is this one. Tangent of 45 degrees is equal to 1. By just knowing that if the angle is 45 degrees and the value of tangent of 45 degrees is equal to 1, okay, you could derive the other functions already. So 45 degrees is a special angle, okay? No matter what you're doing, like what I said, just think of it, if the angle is 45 degrees, the tangent is 1. So if the tangent is 1, you could actually derive the other values. How about 60 degrees? 60 degrees, for me, I'm not so popular with the 60 degrees. But if this is 30 and this is 60, okay, if you know the values of the 30 degrees, okay, you could derive the values of the 60 degrees. So you don't have to memorize the values for 60 degrees, okay, because 30 and 60 are actually what they call this complementary angles, right? The sum of 30 and 60 is actually equal to 90 degrees. So if you know the value of 30 degrees, you could derive the other values of 60 degrees. So there will be no problem with 60 degrees. So actually the only special angle that we need to memorize is actually 30 and 45. Okay, let's try to bring out the solution. Sine of 75 degrees can be written as the sum of two angles. We could represent this as A and this is B. Right? The last time around, we derived the expansion of the sine of the quantity A plus B. So actually, we could express 75 degrees as a sum of 45 and 30 degrees. So it seems A is 45 degrees, or yeah, A is 45 degrees and B is 30 degrees. Right? So if we try to take the expansion of this, we will use formula number 1 the last time around. Like what I said, I've been teaching past 33 years ago, and I could still memorize the formula. So it will still be the sine of the quantity A plus B. Or just make your own code on how to memorize things, right? For me, I just do it like this: sine, cosine, cosine, sine. Okay, this is my code. Meaning, if the required expansion is the sine of two angles, it is sine, cosine, cosine, sine. And then you just place the angles A, this is B, this is A, this is B. And if this is plus, this should be plus. Right? That's the way how do we call this, I formulated my formula for me not to, what you call this, not remembering it. So if it is the sine of the quantity A plus B, I will just see sine, cosine, cosine, sine. Then I will place the first angle, second angle, right? First angle, second angle. If this is plus, this should be plus. Okay? So the solution of example number 1 is actually by using this one. It should be the sine of the first angle times the cosine of the second angle. Second angle is 30 degrees. Plus, this is plus, right? Plus the cosine of the first angle and the sine of the second angle. It is this. Right? And how about the values of sine of 45 degrees, cosine of 30 degrees? Like what I said, just recall your, what you call this, special angles. What angles are here being mentioned over here? 45 and 30. 45 and 30. So actually we could draw a 45 degree triangle, right? Under the hint for a 45 degrees, the tangent of 45 degrees is actually 1. Tangent is actually opposite over adjacent, right? So if the tangent of 45 degrees, okay, is equal to 1, we could place this one as the opposite side to be 1 and the adjacent side is 1 because 1 over 1 is just 1. So if we try to compute for the hypotenuse, Pythagoras, square root 1 plus the square root 1, and that will be square root 2. Okay? So by knowing the hypotenuse, we could now compute for the other trigonometric values of 45 degrees. Okay? You could compute for the sine, you could compute for the cosine, and for the reciprocals, just take the reciprocals, and that's it. Right? So you don't need any calculator or table. How about 30 degrees? There is a 30 degrees here. Later on, we needed the value of cosine of 30 and sine of 30. Okay, just draw a 30-degree triangle. And what is the hand for a 30-degree triangle? Sine of 30 is 1/2. So if this is 30 degrees, the hand is actually the sine is 1/2. So sine of 30 is actually opposite over hypotenuse, right? So if the hand is sine of 30 degrees is 1/2, the opposite side should be 1 and the hypotenuse should be 2. Okay? So if this is 1 and it's 2, we could compute for the adjacent side. Again, Pythagoras principle. The adjacent side should be the square root of 2 minus the square root of 1. After the transposition, then take the square root. So actually, if this is 1 and this is 2, the adjacent side, whether we like it or not, is square root of 3. Okay? So in here, we could compute now for the value of sine of 30 degrees and cosine of 30 degrees without resorting to tables or calculators. Okay, let's proceed. What is sine of 45 degrees? Sine of 45 will be opposite, okay, over hypotenuse. So that is 1 over the square root of 2. I didn't use any calculator or table. I just recall the values of the special angles. I drew the right triangles, and from it I could derive the sine, cosine, and other functions. And what is the cosine of 30 degrees? I go back to the 30-degree triangle. Cosine is adjacent over hypotenuse. That will be square root of 3 over 2. Right? And what is cosine of 45 degrees? Cosine of 45 degrees. Cosine is actually adjacent over hypotenuse. So again, this is 1 over square root of 2. And what is sine of 30 degrees? So that was the hand. Sine of 30 degrees is 1/2. This is opposite over hypotenuse. It is 1/2. So simplifying this one, okay, this is 0.61237. This is 0.35355. And if you try to take the sum, the sine of 75 degrees will be 0.9659. And to check the validity of our answer, okay, we will now use the calculator just to check our answer. You just display 75 here, okay, the proper, what do you call this, signage here will be degrees. Sine of 75 degrees, you take the sine, 0.9659. Okay? So the value of sine of 75 degrees by using the concept of the sine of the sum of two angles is 0.9659, and by using the calculator it is still 0.9659. That is our answer. So you now know the significance of the special angles. Right? Supposing you are on the SAT and CAT exam and they are asking for the sine of 75 degrees, no calculators allowed. So the proper solution will be just to bring out the special angles. Just recall the head on the special angles. You could construct the resulting right triangles. And from it, you could get the value of the other trigonometric function. Okay, let's proceed with example number 2. For example number 2, it's an easy one. Find the sine of 60 degrees. 60 degrees. Actually, the sine of 60 degrees is 0.866, but we wanted that the solution of this one will be a solution by using the expansion of the sine of the sum and difference. Okay? Or sine of 60 degrees, we'll do it like this. Sine of 60 degrees Or just think of two angles in which if you try to subtract, what will come out will be 60 degrees. I think the best solution for this one is 90 degrees is a special angle, and 30 degrees also a special angle. So again, by using these two angles here, in which the difference is actually 60 degrees, okay, we could compute for the value of sine of 60 degrees without resorting or using trigonometric tables or calculator. Okay, sine of 60 degrees, it will be sine of the quantity 90 minus 30. Okay, let's try to bring out the expansion of this. Sine of the quantity a minus b. Okay, I will just use my code 33 years ago. It will not change, right? So if you got a code and you can recall it, there will be no problem. It will be still be sine, cosine, cosine, and sine. This is the code. The expansion of this one, for me, my code is sine, cosine, cosine, sine. So the sine of the first angle, cosine of the second angle, if this is minus, this should be minus, right? Cosine of the first angle, sine of the, no, first angle, sine of the second angle. Sine, cosine, cosine, sine. Okay? It's almost the same as the first one, except that if this is plus, this should be plus, but since this is minus, this should be minus. So if we try to expand the sine of 90 degrees, quantity 90 minus 30, we'll just follow this one. It should be the sine of the first angle is 90, cosine of the second angle, since this is minus, this should be minus, cosine of the first angle, and the sine of the second angle. And again, if you are on the SET or CET exam, no calculators allowed, since the resulting angle inside are actually special angles. You could derive the values without resorting or without using tables or what you call these calculators. For 90 degrees, I want to show you the 90 degrees. It will be something like this. 90 degrees is actually, it emanates from a right triangle, right? Right? It is something like this. If we try to rotate this roller here, we'll do it upward like that. As we rotate it clockwise, there will be an angle between this 0 degree and the hypotenuse, right? But the problem with 90 degrees is that, okay, it keeps rotating, then it goes vertical. Okay, it is like this. It goes vertical. So it seems the adjacent side is actually, the adjacent side is equal to 0, and the opposite side will now be equal to 1. Okay? It is originally like this. We try to rotate this one counterclockwise, then as soon as it reaches 90 degrees, okay, there will be no more horizontal component. It is just a vertical component, so it is just only this. Okay? So to compute for the sine and cosine of 90 degrees, just think of it as this is 1, right? So the hypotenuse now, as soon as the angle reaches 90 degrees, okay, the opposite side, the opposite side is now equal to the hypotenuse. And then it is equal to what? It is. No more adjacent side. It is just a plain vertical thing, right? In which this vertical thing is the original opposite side. And unluckily, at the instant of 90 degrees, this opposite side is now equal to the hypotenuse. So in here, the adjacent side will be 0. So if we try to get the value of sine of 90 degrees, many of you don't what they call this is familiar with the sine of 90 and cosine of 90. This is the trick now. Sine of 90 now will be a 1 over 1, and it is actually 1. Why it is 1? Because at the instant that the opposite side is actually upright, vertically upward, the opposite side is now equal to the hypotenuse. So if we try to take the ratio of 1 over 1, what will come out will be 1. Right? So sine of 90 degrees, okay, will be equal to 1. No matter what happens in this world, the sine of 90 degrees will always be 1. And the derivation of that is, it is this. It is 1 over 1, or this is 1. Because at the instant that the, what they call this, the opposite side is upright, it seems this is now the opposite side, and at the same time, this is now the hypotenuse. So if we try to take the ratio of opposite side over hypotenuse, it should be 1 over 1. Okay, 1 over 1. So this is now equal to, sine of 90 degrees will now be equal to 1. And for the cosine, okay, this is why the cosine of 90 degrees is 0. It actually emanates from this one. The cosine of 90, what's the definition of cosine? Cosine is actually adjacent side over hypotenuse, right? Okay, adjacent side over hypotenuse. But at the instant that this opposite side is actually vertical, no more opposite side, no more adjacent side, right? It is standing upright, no more adjacent side, okay? So if we try to take the cosine of 90 degrees, it should be 0 divided by the hypotenuse when it is upright, it is 1. So 0 over 1 will be equal to 0. That is why if the angle is 90 degrees, the cosine is 0. Okay, this is where the sine of 90 equal to 1 and cosine of 90 equal to 0 emanates. This is the origin, right? So by knowing this one, you don't have to use your calculator or your trigonometric table. If you say 90 degrees, automatic the sine is 1, right? For cosine, no adjacent sides. So a 0 over 1 will be 0. So cosine of 90 degrees is actually 0. So actually in here, we could compute from here, express, we got already the sine of 90 degrees and the cosine of 90 degrees, right? About cosine of 30, just go back here. Cosine of 30 is actually this 30 degrees, right? It's a square root of adjacent over hypotenuse. This is a square root of 3 over 2. And how about the sine of 30? Sine of 30, 30 degrees is the hand. For a 30 degrees, actually sine of 30, it's 1/2. So this is actually 1/2. Okay? Since sine of 90 is actually 1, this should be 1 times cosine of 30, which is square root of 3 over 2 minus cosine of 90 is actually 0, and sine of 30 will be 1/2. 1 times square root of 3 over 2, this will be 1.732 divided by 2, this will be 0.866. And 0 times 1/2 will be 0, and 0.866 minus 0 will just be simply 0.866. Therefore, the value of the sine of 60 degrees by using the expansion sine of the difference of 90 minus 30, it is 0.866. Right? You just display 90, sine of 90 degrees is 1. That's why, but this one here actually emanates from this one. This is the derivation, because 90 degrees is spatial angle. About 90 degrees, cosine of 90 degrees is 0. Why it is 0? It emanates from this one. It should be a 0 over 1, or this will be 0. Because at the instant, okay, that it is vertical, no more adjacent side. So if you try to take the definition of a cosine, it should be adjacent side over hypotenuse. But the adjacent side is 0. Okay, is 0. And the hypotenuse now, luckily it is the vertical thing. It should be 1. Okay, so a 0 over 1 will be equal to 0. So from now on, if you say 90 degrees, the cosine is 0, and the sine of 90 degrees is 1. Okay, that's it guys. This is Professor David J. De Los Reyes from Los Angeles. Good evening.